So we're going to be trying this problem at 25 degrees Celsius. What's the molar solubility of PbI2? So that has a Ksp value. So we know that we can go ahead and write an equilibrium for this. And we especially want to do that because one thing that we're going to notice is that there are in fact two iodide molecules. So if you'll remember, that two's got to be there in our stoichiometry. And then as we look at this, since we want Ksp, we can in fact think of this as we've thought of our rice tables. It's been a while since we may have written one of these out, but we can still think of it that same way. And remember, this is a solid, so all of our solid species, they're not going to be changing concentrations as we go, whereas our aqueous species will. So as we start out, we won't have any of our aqueous species to start off with, but then we're going to gain X, and we're going to gain twice as much of the iodide as the lead. So that'll leave us with these. Our Ksp expression is going to involve both the concentration of lead as well as the concentration of our iodide, but that's going to be squared. So that's something that goes back to how we write our expressions for Ksp. We're going to have that squared function thanks to our coefficient, and that again goes back to how we write K expressions, something we did way back in chapter 15. So again, it may have been a while, but the nice thing is that we've got our Ksp value, and we now have ways to relate our lead to our iodide concentration. So we have our X and our 2X, and that's all squared. So it is important to remember that that 2 goes inside of the parentheses, so that way when we actually are working on the math portion of this, we are going to have X, and then this is then going to be times 4X squared. So do remember to square your 2 as well. Continuing to simplify, we'll have 4x cubed. So at this point, I can then go ahead and grab my calculator. And I'm going to use that second EE button in order to actually do this. There's my Ksp value, divided by 4. And then what I'm actually going to do, I then am going to need to take the cube root. Now there's a couple of different ways you can do this on your calculator. Personally for me, I actually prefer to just raise everything to the 1/3 power. So that actually is the same thing as the cube root, and personally I just think it's the easier way to do it. There is another button on your calculator that will do that as well. That's actually going to be the button that's right above the caret. So that should work as well, but again, I find this to usually be a little bit more foolproof, and the faster we have to go on exams, the more we like things to be as simplified as possible. It's going to be 1.52 times 10 to the negative 3. It's supposed to be the number 5. So now we have our X, and that's all well and good, but we want to look at what the question actually asked us. Well, the question was molar solubility. So you guys need to remember that molar solubility, this is supposed to be the moles per liter that of our lead iodide that dissolves. Now this always seems a little bit strange because we're asking for a concentration when we're staring at a solid. So it always seems a little bit counterintuitive. But if you'll remember, we could actually do this in grams and ask, well, how many grams of this dissolve? And then that seems to make a little more sense. So all we're really doing is asking about moles. Well, in order to do that, what we really want is, since we really want our lead iodide here, what we're really looking for then is something that's going to be in a 1-to-1 ratio with our lead iodide. So whenever you guys are doing these problems, the answer pretty much is almost always X, because really what you're looking for is something in a 1-to-1 ratio with this original salt. So your X value, the way that we've been using our rice tables, is pretty much always going to be in that 1 ratio of our salt. So in this case, you get this final number for X. This is in molarity, that is a concentration, and that X is also going to be your molar solubility. So your molar solubility is 1.52 times 10 to the negative 3 molar. That also happens to be the concentration of lead iodide in solution. And if you actually wanted to go back, if the question asks you, for example, for your iodide concentration, you could go back and look at your iodide concentration instead.